Hey guys, in this video I'm going to give you the general setup for a strict sequencing game. This game is from the June 2007 LSAT, which I also call PrepTest 51.5 because it was administered right between PrepTest 51 and PrepTest 52. So this game was a little bit tricky because it actually uses numbers as the variables. The digits 0, 1, 2, 3, and 4 are our variables that we're placing in order from first through fifth. Now, this game is a strict sequencing game, or at least I think about it that way, just because we have a 5-digit number that we're creating, so there's a first digit to that number, a second digit, and a third digit, etc. So I've numbered 5 different spaces, 1 through 5. And our digits 0, 1, 2, 3, and 4 are listed up here on the left. The second rule telling us that each digit occurs exactly once is simply ensuring that we're going to use all 5 of the digits 0, 1, 2, 3, and 4. The next rule tells us that we have a second digit that's twice the value of the first digit. So our second digit then has to be an even number because the first digit times 2 is guaranteed to give us an even number. Whenever you multiply anything by 2, you end up with an even number as your product. So looking at our 5 digits here, the number 2 and the number 4 are both even digits. None of the other ones are. So I'm going to lay out 2 different main diagrams here. One where the second digit is number 2, and one where the second digit is number 4. Now, of course, if the second digit is 2, the first digit will have to be 1, and if the second digit is 4, then the first digit will have to be 2. Now that we've broken the game into these 2 different main diagrams, let's take a look at the remaining rule, which tells us that the third digit must be a lower value than the 5th digit. So whatever's on number 3 here must be a lower number than whatever's on number 5. So since we've already used up 2 digits out of 5 for each of these possibilities, the remaining options for each of our main diagrams here are pretty limited. So in the top diagram here, where we've already used up 1 and 2, we have the digits 0, 3, and 4 remaining. And there are 3 different ways this can play out. We can either have 0 on 3 and 3 on 5. We can have 0 on 3 and 4 on 5. Or we can have 3 on 3 and then have 4 on 5. And this, of course, tells us exactly whatever's remaining is going to have to go in the 4th, which of course would be the remaining variables for each of these possibilities, which would be 0, 3, or 4, depending on which diagram we're dealing with. In the bottom possibility, since we've already used up 2 and 4, we only have the variables 0, 1, and 3 remaining. So same thing, only 3 possibilities emerge. We could have 0 on 3 and 1 on 5. We could have 0 on 3 and 3 on 5. Or we could have 1 on 3 and then have 3 on 5. And then, of course, whatever is remaining is going to have to go in the 4th space once again. So that could be 0, it could be 1, or it'll be 3, depending on which of these possibilities we're dealing with. So as you see, there are only 6 possible options total for what's happening in this game overall. Only 6 possible orderings of digits comprise all of the possibilities for this logic game. Now that we've done the setup for this logic game, let's take a look at the questions. So the first question is saying, if our last digit were 1, what must be true? So if the final digit were the number 1, that limits us to only this bottom possibility, 2, 4, 0, 3, 1. That is the only valid scenario where our final digit is the number 1. So they're asking us what must be true. We'll just run through the choices. Must the first digit be 2? Yes, it must. That definitely happens in this possibility. So A is our answer for number 1. I will look at the rest of the choices though. Must the second digit be 0? No, the second digit is 4, so B is gone. The third digit's 3, no, the third digit is 0. Fourth digit 4, no, it's 3. Fourth digit 0, no, once again it's 3, so A is our answer for number 1. Next, number 2, what must be true for every single possibility for this game? So the correct answer choice will have to hold true to all 6 of these listed possibilities. 1 occurs earlier than 2, happens in the first 3 possibilities, but not in the second 3 possibilities, so A is not a must. 1 appears before 3, happens in the first 3 possibilities, happens in the 4th and 5th possibilities, but does not happen in the bottom possibility, so therefore it is not a must and B is gone. 2 earlier than 3 happens in the first possibility, the second, and the third, the 4th, the 5th, and the 6th. Happens across all 6 of these, and as we know, these 6 comprise all of the possibilities for the game, so C is a must and is our answer to number 2. I'll go through D and E though. 3 earlier than 0 happens in the first possibility, does not happen in the second, the third, the 4th, 5th, or 6th, so it is certainly not a must. It only happens in 1 out of 6, and in order to be a must, it must happen in all 6 out of 6, so D is gone. Then looking at E, 4 earlier than 3, must that be the case? Happens in all 3 of the bottom 3, happens in the third diagram, but does not happen in the first 2, so because it does not occur in all of them, it is not a must, and E is gone, leaving C. Next, number 3, if the third digit were not 0. So let's eliminate all the possibilities where the third digit is 0. Getting rid of the second and third ones, getting rid of the 5th and 6th ones. So we're left with the 1st and the 4th, and that's it. These are the only 2 that are relevant to this question. So they're asking us what must be true. Must the second digit be 2? Happens in the first possibility, but not in the second valid possibility, so A is gone. Must the third digit be 3? Once again, happens in the first possibility, but not in the second valid possibility here, so B is gone. Must the fourth digit be 0? Happens in the top one and the second one, so C is our answer. We're good. Those are the only 2 that are relevant. I will go through D and E though. Must the 5th digit be 3? Happens in the bottom one, but not the top one, so D is gone. Then E, 5th digit is 1, happens in neither of these, so it's certainly not a must. So E is gone as well, leaving C. Next, number 4. For this question, they're giving us a list of 4 choices that do comprise an accurate list of the third and fourth digits in a valid scenario, and one of these choices could not be the third and fourth digits within a given scenario. So let's find the 4 choices that do appear in our diagram and eliminate them, and whatever remains will be our answer. So 0 on 3 and 1 on 4. That does happen in the 5th possibility. 0 is 3, 1 is on 4, so A is gone since it could happen. 0 and 3 on the 3rd and 4th spaces. Happens in the bottom diagram and in the second one. It certainly could be the case, so B is gone. Choice C, 1 and 0. That happens in the 4th possibility right here, 2, 4, 1, 0, 3. So C is gone. D, 3 and 0, happens in the top possibility, so D is gone, leaving E by elimination, 3 and 4. As you see, that only one possibility, the top one, has 3 in the 3rd space, but that possibility has 0 in the 4th space, not the variable 4. So E is invalid, could not be the case, therefore it's our answer to number 4. Finally, number 5, what must be the case in general for any valid scenario? We'll just run through the choices. Exactly 1 digit between 0 and 1. That does not have to be the case. In the top possibility here, we have 2 variables between 0 and 1. Additionally, in the 4th and 5th possibilities, they're consecutive, adjacent, they're touching, and there are 0 variables between them, so A is certainly not a must. Looking at B, exactly 1 digit between 1 and 2. Definitely not. In the top 3 possibilities, there are 0 digits between 1 and 2. And in the 5th and 6th possibilities, there's more than 1 variable between them. In the 5th possibility, there are 2 variables between them. And in the 6th possibility, there are 3 variables between them. So B is gone. Next, looking at C, at most 2 digits between 1 and 3. Must there be at most 2 digits between 1 and 3, or could there be more than 2 digits between 1 and 3? There actually could be more than 2 digits between 1 and 3. In the 3rd possibility here, we have the variables 2, 0, and 4 between the variable 1 and the variable 3. So that would be 3 variables, more than 2 digits, so C is gone. Not a must. Looking at D, at most 2 digits between the digit 2 and the digit 3. Must there be at most 2 digits between 2 and 3? Let's take a look. No, in the fourth and fifth possibilities here, we have 3 digits, the variables 4, 0, and 1 occurring between 2 and 3. So there aren't at most 2 digits between them. There could be 3 digits between them, so D is gone, leaving E by elimination. And if we look at E, at most 2 digits between 2 and 4. Must that be the case, or could we have 3 digits between them? Well, of course, having 3 digits between them would mean that we have 2 and 4 on the endpoints, meaning one of them is on the first space and one of them is on the fifth space. And as you see, that never occurs. We never have one of 2 and 4 on the first space and one of 2 and 4 on the fifth space. That never happens, meaning we never have more than 2 digits between 2 and 4. So E is our answer for number 5.